Good morning, students. I hope all you are safe. And in this maths class, we are going to learn the modulus of a complex number. In the previous classes, we learned conjugate of a complex number. Say, modulus of a complex number measures the distance of that number from the origin in the complex plane. Modulus of a complex number measures the distance of that number from the origin in the complex plane. Say when we draw a graph, this is a real part and here it is imaginary part. And if z is equal to x plus iy, so x comma y, x real part somewhere here and y. So I can mark it x comma y. So when I connect it, this is x and this is y, isn't it? So if I join this is what they have mentioned, the distance from the origin to the complex. See? This is a right angled triangle. So by Pythagoras theorem, that is root of sum of the squares of the other two sides. So we make it x square plus y square. Say the definition is if z is equal to x plus iy, then the modulus of z, that we will be denoting it as modulus z, and is defined by modulus z is equal to root of x square plus y square. Root of, for example, modulus 2 plus I. So that is root of 2 square plus 1 square. Then we can simplify and write the answer, that is root 4 plus 1, which is equal to root 5. Then, or one more example, 2i. Here there is no real part, so 0 square plus imaginary part 2 square. So root 4, which is equal to 2. Do you understand how to find out the modulus? Very simple, isn't it? Now from that we are going to do some other properties. See here, z is equal to x plus iy means we know z bar equal to x minus iy. And for z, modulus z equal to root of x square plus y square. Now just to find out what is z into z bar. Z is x plus iy and z bar is x minus iy. So when we multiply this, we will be getting x square plus y square. Already we have learned, isn't it? See, this I am writing it as square root of x square plus y square the whole square. I can write it, isn't it? Now I know that root of x square plus y square is modulus z. So we make it, that is modulus z the whole square. So z into z bar is equal to modulus z the whole square. In most of the proofs we will be using this, okay? That is z into z bar is equal to modulus z the whole square. Now properties of modulus of a complex number. Modulus z will be equal to modulus z bar. Say this modulus z is root of x square plus y square. For this you can find out modulus z bar. What we may get it ma root of x square plus imaginary part, that is minus y the whole square. So x square plus y square. Both are same, isn't it? Here also root of x square plus y square and here also we have got it root of x square plus y square. So modulus z is equal to modulus z bar. The second one, modulus z1 plus z2 is always less than or equal to modulus z1 plus modulus z2. This is triangle inequality. An important proof. After this property we will prove it. An important one. Modulus z1 plus z2 is less than or equal to modulus z1 plus modulus z2. Now when we multiply, that is same, it will be equal to modulus z1 into modulus z2. When we divide also, we will get modulus z1 by modulus z2. But when it is in plus, it is less than or equal to. If it is with minus, that is greater than or equal to modulus of modulus z1 minus modulus z2. Why again this modulus is given? See, suppose if modulus Z2 is greater than modulus Z1, we will get a negative value here. In order to make it positive, it is given modulus of modulus Z1 minus modulus Z2. Now, Z power n, the modulus is equal to modulus Z the whole power n, comma n is any integer. And real part of Z is always less than or equal to modulus Z. Real part of Z is actually x, isn't it? So that will be always less than or equal to modulus Z. The same way, imaginary part of Z is y. That y will be always less than or equal to modulus Z. Some property we will prove it, and some of the property we have to use in the problems. Okay. Okay. That state and prove triangle inequality. For any two complex numbers Z1 and Z2, we have modulus Z1 plus Z2 is less than or equal to modulus Z1 plus modulus Z2. This is what triangle inequality I said, isn't it? Shall we prove it? Say, in order to prove that, I am just taking modulus Z1 plus Z2 the whole square. Okay, left hand side actually we have modulus Z1 plus Z2. To prove that, I have taken square. See, we have learned that modulus Z the whole square is Z into Z bar. Z into Z bar, we proved that is modulus Z the whole square. So, I am writing it as Z into Z bar, that is Z1 plus Z2 into Z1 plus Z2 the whole bar. Is that clear? Now, Z1 plus Z2, this bar we can separate, isn't it? Z1 bar plus Z2 bar. Here also you can write it Z1 plus Z2, the whole bar can be written as Z1 bar plus Z2 bar. This also we have learnt already. Now, ordinary multiplication. Multiply it, we may get Z1 into Z1 bar plus Z2 into Z1 bar. Now, multiply with Z2 bar. Z1 into Z2 bar plus Z2 into Z2 bar. We have did the ordinary multiplication. See, this one we knew Z1 into, see, Z into Z bar means modulus Z the whole square. This I can write it modulus Z1 the whole square. This last term also we can write it modulus Z2 the whole square. So remaining, see, this is a square plus b square. In between actually we need a term 2ab. But here you see Z2 Z1 bar and this is Z1 Z2 bar. See, I am writing Z1, this one, Z1 Z2 bar the whole bar. This one I am writing as it is. See, Z bar the whole bar is again Z, isn't it? That we know. We have learned Z bar the whole bar is equal to Z. See, Z bar the whole bar, that is Z. This is Z1 bar. So, value did not change it. Now, this together I am going to take it as Z and this is Z bar. See, Z plus Z bar by 2 is equal to real part of Z. This one we have proved in the last exercise. Real part of Z is equal to Z plus Z bar by 2. So, from this Z plus Z bar is equal to 2 into real part of Z. Now, if you are considering Z1 into Z2 bar as Z, we may get modulus Z1 the whole square plus 2 into real part of Z1 Z2 bar plus modulus Z2 the whole square. Is that clear? Now, I have to remove this real part. See, just before in the properties we learned real part of Z is always less than or equal to modulus Z. Real part of Z is always less than or equal to modulus Z. So, equal to will become less than or equal to modulus Z1 square plus 2 into modulus Z1 into Z2 bar. plus modulus z2 the whole square. Is that clear? Now I am going to write equal to modulus z1 square plus 2 into, we can separate it, isn't it? Modulus z1 into modulus z2 bar plus modulus z2 the whole square. This we have used. Now again, we know that modulus z bar is equal to modulus z. First property we learned that only, isn't it? So I can write which is equal to modulus z1 square plus 2 into modulus z1 into modulus z2 plus modulus z2 the whole square. Now we have got it, a square plus 2ab plus b square. So that is a plus b the whole square, that is modulus z1 plus modulus z2 the whole square. Now actually left hand side we had modulus z1 plus z2 the whole square, and in between what symbol is there? Less than or equal to, and the answer is modulus z1 plus modulus z2 the whole square. Both square is there, isn't it? Take square root on both sides. So you make it modulus z1 plus z2 is less than or equal to modulus z1 plus modulus z2. Is that clear? Important proof. This is what we used to say it as triangle inequality. So similarly, if it is modulus z1 plus z2 plus z3 plus etc. plus zn, this will be less than or equal to modulus z1 plus modulus z2 plus modulus z3 plus etc. plus modulus zn. Okay. So the next, the distance between 2 points z1 and z2 in complex plane is modulus z1 minus z2. Here also the question can be asked, 3 vertices can be given and they may ask us to check whether the vertices forms a equilateral triangle or right angled triangle. That means we have to find out the distance, isn't it? To find out the distance, that is modulus z1 minus z2. See, if z1 equal to x1 plus iy1 and z2 is equal to x2 plus iy2, then modulus z1 minus z2 is, see, when we subtract this to real part, x1 minus x2 plus I into y1 minus y2. Now we can find out the modulus value, that is root of real part to the whole square plus imaginary part to the whole square. So we are getting x1 minus x2 the whole square plus y1 minus y2 the whole square. This is the ordinary distance formula, isn't it? Yeah. Now some of the remark that is very important one we will be using. Say modulus z1 minus z2 is less than or equal to modulus z1 plus z2. Modulus z1 minus z2 is less than or equal to modulus z1 plus z2. This is 1. And modulus of z1 minus modulus z2 is always less than or equal to modulus z1 plus z2. And as per triangle inequality, we know this is less than or equal to modulus z1 plus modulus z2. Okay. Also, or and modulus of modulus z1 minus modulus z2 is less than or equal to modulus z1 minus mod z2. This, as per this we can write modulus z1 minus z2 is less than or equal to this. It will come, isn't it? But that one's result is modulus z1 plus modulus z2. This we have to use it into 3 problems. Okay, modulus of modulus z1 minus modulus z2 is less than or equal to modulus z1 plus z2, and that will be less than or equal to modulus z1 plus modulus z2. The same way, modulus of modulus z1 minus z2 is less than or equal to modulus Z1 minus Z2 less than or equal to modulus Z1 plus modulus Z2. Now we can move to the problems. See example 2.9. If Z1, Z2, Z3 is given. Find modulus Z1, modulus Z2, modulus Z3, modulus Z1 plus Z2, modulus Z2 minus Z3 and modulus Z1 plus Z3. Simple one, modulus Z1, that is modulus Z1 value is 3 plus 4i, which is equal to, shall we find out? That is root of 3 square plus 4 square. Root 3 square is 9 plus 4 square is 16. So we may get that is root 25. Root 25 we know the answer, that is 5. If you are unable to take it out from the root, we can keep as it is. Now modulus Z2, that is modulus 5 minus 12i. So this is root of real part 5 square plus imaginary part minus 12 the whole square. So 5 square 25 plus 12 square 144. 25 plus 144 169. This is also a square number 169. 13 into 13 is 169. So our answer is 13. Then modulus Z3. It's modulus 6 plus 8i. That is root real part 6 square plus imaginary part 8 square. 6 square 36 plus 8 square 64. 36 plus 64 is 100. Root 100. We know that 10 into 10 is 100. So square root of 100 is 10. Then the next one is modulus Z1 plus Z2. This Z1 3 plus 4i plus Z2 5 minus 12i. First we have to simplify this. We have to make it together the real part and imaginary part. 3 plus 5, 8. 4i minus 12i, that is minus 8i. Now we can find it out. Root of real part 8 square plus imaginary part minus 8 the whole square. That is root of 8 square 64 plus again 64. That is root 128. Or this can be written as 64 into 2. So we can write it as 8 into root 2. 64 is 8 into 8, isn't it? That is why we can write it as 8 into root 2. Is that clear? So two more things we need to find out. Z2 minus Z3 and Z1 plus Z3. Modulus Z2 minus Z3. See, first I have substituted the value 5 minus 12i. Subtract it to minus 6 minus 8i. So 5 minus 6, that is minus 1, minus 12i minus 8i, that is minus 20i. Now we can find it out. Root of minus 1 the whole square plus minus 20 the whole square. 1 plus 20 square is 400. That is root 401. This is not a square number, so we can keep as it is. The last one they have asked is Z1 plus Z3. It's modulus 3 plus 4i plus Z3 is 6 plus 8i. It's enough to add, isn't it? 3 plus 6, 9 plus 4i plus 8i is 12i. Now this is root of 9 square plus 12 square, isn't it? Modulus of 9 plus 12i is root of 9 square plus 12 square. Root of 9 square 81 plus 12 square 144. 81 plus 144 is 225, and this is a square number. 15 into 15 is 225. So our answer is 15. Do you understand this? The next example is find the following. See, this both separate is there, isn't it? Numerator and denominator. We know that modulus Z1 by Z2 is equal to modulus Z1 divided by modulus Z2. So here also we can separate it. 2 minus I by modulus minus 1 plus 2I, which is equal to root of 2 square plus minus 1 the whole square divided by root of minus 1 the whole square plus 2 square. Both the same, isn't it? Root 4 plus 1, and here it is 1 plus 4. Root 5 by root 5, which is equal to 1. Even from here also you can cancel because both numerator and denominator same terms is there, okay? Now the second subdivision is modulus 1 plus I bar into 2 plus 3I into 4I minus 3. See, Z1 into Z2 modulus is equal to, you can write modulus Z1 into modulus Z2. So shall we separate it? That is modulus 1 plus I bar into modulus 2 plus 3I into modulus 4I minus 3. Okay, this is same as modulus Z is equal to modulus Z bar. So direct value we can write it, root of 1 square plus 1 square. Here root of 2 square plus 3 square. Here root of real part minus 3 the whole square plus imaginary part is 4 square. This is root 1 plus 1 into root 2 square is 4 plus 3 square is 9 into root minus 3 the whole square, 9 plus 4 square is 16. So this is root 2 into root 13 into root 25. This root 2 into root 13 we can write it as root 26. Root 25, we know 5 into 5 is 25. So we can take it out from the root. So our answer is 5 into root 26. Simple problems only, isn't it? One more subdivision is there. That's subdivision 3. Modulus I into 2 plus I the whole cube by 1 plus I the whole square. See, we can separate it. Modulus I into modulus 2 plus I the whole cube by modulus 1 plus I the whole square. Because we know modulus Z power n modulus is equal to modulus Z power n. Now we can give the formula. See, I, this is root 1 square. Here root 2 square plus 1 square divided by root 1 square plus 1 square. Root 1 square is 1 and this is root 2 square, 4 plus 1 by 1 plus 1. So we make it root 5 by root 2. And here actually what is there? Cube. So we can give cube and here it is the whole square. So root 5 the whole cube by root 2 the whole square. Root 5 the whole cube. What is the meaning? Root 5 into root 5 into root 5. So instead of root 5 into root 5 we can write it 5. So our answer is 5 into root 5. And the denominator root 2 the whole square. Root and square will be removed and our answer is 2. So for the last subdivision the answer is 5 into root 5 divided by 2. Next example 2.11. Which one of the points I comma minus 2i plus minus 2 plus I and 3 is farthest from the origin? So from the origin, which of the point will be the farthest, that which will give the longest distance? Say distance between origin 2, that I am taking it as Z. The values are I, minus 2 plus I and 3 R. All actually modulus, that is Z minus 0. The origin is 0, isn't it? So all you can find out the modulus value. Say modulus I. If I take only I, we may get that is root 1 square, which is equal to 1. Now the same way, this for the second value. Modulus minus 2 plus I. 0, we can leave it, isn't it? Root of minus 2 the whole square plus 1 square. Root 4 plus 1, that is root 5. The last value, that is modulus 3. Only real part is there, that is 3 square, which is equal to 3. So which point is the farthest? This root 5 may be 2 point some number, isn't it? So the greatest value is 3. Or if we can, this one is the smallest among this, and the next is root 5 and the next is 3. Among this, the highest value is 3. Therefore, I can write, therefore, the farthest point from the origin is 3. So you have a homework problem, that is the least point or the nearest point. Nearest point also what we should do? First we have to find out all these 3 values, and then the smallest one value we have to write the nearest point from the origin is. Is that clear? Nearest point or the closest point from the origin. Okay. See the next easiest problem but important. If Z1, Z2 and Z3 are complex numbers such that modulus Z1 equal to modulus Z2 equal to modulus Z3 equal to modulus Z1 plus Z2 plus Z3 equal to 1. Find the value of. For this we have to find out the value. These are the given values. See, I am taking since modulus Z1 equal to modulus Z2 is equal to modulus Z3 is equal to 1. This is also equal to 1. I am just taking these 3 values. See, this modulus Z1 equal to 1 implies modulus Z1 the whole square also will be equal to 1, because I wanted to remove this modulus. See, this can be written as Z1 into Z1 bar is equal to 1. Is that correct? Because we know modulus Z into Z bar equal to modulus Z the whole square. Now, here we need 1 by Z1, isn't it? So, find it out. Z1 bar is equal to 1 by Z1. Okay. The same way, modulus Z2 is equal to 1. So, modulus Z2 the whole square is equal to 1. Z2 into Z2 bar equal to 1. From this, Z2 bar is equal to 1 by Z2. Similarly, see Z3 bar is also equal to 1 by Z3. Now we can find it out. What is modulus? 1 by Z1 plus 1 by Z2 plus 1 by Z3. Modulus 1 by Z1 plus 1 by Z2 plus 1 by Z3 is equal to, actually 1 by Z1 is Z1 bar plus 1 by Z2 is Z2 bar and 1 by Z3 is Z3 bar. Say Z1 bar plus Z2 bar plus Z3 bar, I can write it as Z1 plus Z2 plus Z3 the whole bar. Isn't it? We know that modulus Z is equal to modulus Z bar. So I can write it as modulus Z1 plus Z2 plus Z3. See in the question they gave modulus Z1 plus Z2 plus Z3 is equal to 1. Therefore, the value of modulus 1 by Z1 plus 1 by Z2 plus 1 by Z3 is equal to 1. Is that clear? Do you all understood this? Now the homework part. Exercise 2.5, first one. Find the modulus of the following complex number. See this, you can separately find out the modulus, isn't it? 2 by 5 is the answer. And here you check, this is in between plus, isn't it? If it is division or if it is in multiplication, you can separate the modulus. If it is in plus or minus, first you have to simplify that. Take LCM. Okay, after that simplify and then find out the modulus. The answer is 2 root 2. Here we know this, modulus the whole power 10. So here the answer is 2 power 5. This you can separate, find out the modulus. The answer is 50. Now problem number 3. Which one of the points 10 minus 8i and 11 plus 6i is closest to? In that classwork example problem, we did farthest to the origin, isn't it? So we found out z minus 0. Here actually you should find it out first, modulus 10 minus 8i minus 1 plus i, because we have to find out the distance, isn't it? The same way next, 11 plus 6i minus 1 plus i. Is that clear? Find it out the answer. Here actually your answer will be root 162 and here your answer will be root 125. Among this, which is the least value? Root 125 is the least value. So the point 11 plus 6i is the closest point, closest to 1 plus i. So actually we have to find out the distance from that point and we should write the answer. Is that clear? Complete this homework. The continuation of this class we will take in the next section. Okay. Thank you students. Bye-bye.